tutorial videos just to give you another opportunity to go through the material. I'll try to tell you where there's activities built in so you can stop and go into Canvas and work through those activities just to kind of give yourself some practice. I'm going to try to keep these to just being basic explanations and working through some examples. The very first thing that we will do is we will talk about the real number system, and then we'll transition into algebraic expressions. So the very first thing is the real number system. You've got to know how it's all structured. So this is just going back and just thinking about how you learned numbers and how it's built. So we're going to use a diagram to show you subsets. So the very first set of numbers that you ever learned, you learn to count 1, 2, 3, 4. So these are called either counting numbers or natural numbers. So the math word is natural numbers. So we're gonna make ourselves a little box here, and we're gonna put natural numbers. But like I said, it could be counting numbers. But these are the numbers 1, 2, 3, so on and so forth until you get larger. Okay, and then what you do after that may not necessarily be the way you learned numbers, but the way it grows as a system. It actually changes the name of the group if all you do is add 0. It makes it the whole numbers. Whole numbers, you just put 0 in the mix. So, come on. Oh, got a little big, didn't it? So we have 0, 1, 2, and keep going. All right. Now, say you add another level or increase it. So what if we put negative numbers with it? So, and these are all, and I'm just generically using the word numbers here. But if I have ... -2, -1, 0, +1, +2, keep going. Those are known as the integers. Okay, so all negatives, 0, and all positives. That creates the integers. Okay. Next set. What if I throw in fractions? Anything that can be written as a fraction. So that would be, hopefully you're remembering, that means that we're talking about the rational numbers. Anything that can be written as a fraction or repeating decimal. I ran out of space. Okay, well that makes us think, well if that's the case, then what if it can't? Because that's the big can word. Well if it can't, they have absolutely nothing in common. So all these others were subsets of each other. So integers is a subset of rationals. Whole numbers are a subset of integers, and natural numbers are a subset of whole numbers. So they kind of nest inside of each other. But then you have this group that has nothing to do with the others, and that is the irrationals. So irrational numbers, it's basically you take the definition for rationals. So any number that cannot be written as a fraction, and I'm going to run out of room, or repeating decimal. It's not keeping up, is it? Okay. Now, the question is, what kind of numbers do that? For rational numbers, I mean, it's easy. You can write them as fractions. And think about it. If I had 12 over 4, well, that's just 3. So that makes perfect sense that whole numbers and natural numbers are subsets of rational numbers. But if I had 12 over, 5, can't reduce that, but it is a fraction. I can write it as a fraction, so it's rational. So how do you get one that's not rational? The way some of them are just numbers that we accept in math that have a definition, like pi. Pi, a lot of people say it's 3.14 or 22 over 7. Those are approximations. Pi never stops. It's irrational, transcendental actually. So we have pi. There's also a number, Euler's constant is E. It's, again, doesn't stop, doesn't repeat. And then anytime you have a square root that cannot be reduced. So if I have square root of 2, square root of 3, I can't do those. Now, square root of 4, I can do square root of 4. Square root of 4 is actually 2. So square root of 4 actually goes all the way into the natural set. That's the smallest subset that it belongs to, because that's just whoops, I wrote the wrong thing. I said 4 and root 2. Okay, so square root of 4 is equal to 2. That means that it goes into the natural. So you have to be careful. Only the ones that cannot be reduced are the ones that are irrational. And all of this set, all of it combined, let's see here, what have I not used? Purple. So all of this together, the whole thing, makes the real number system. Okay? So later on in this year, we will actually learn the last set of numbers that exist. So it's not just the last set that you're going to learn this year, it's the last set of numbers that you need to learn about. And so there's one more layer that we will add to it around, I guess around Thanksgiving or so. We'll learn that and top all this off. That gives you an idea of the real number system and how it works. Now there is an activity on Canvas that I want you to go to, and it basically has that, let's see if I can get there. Okay, so if you click on, now this is the teacher view, so yours will look slightly different, okay? But if you go to your Canvas course, and then you go down to Unit 1, and then you find Unit 1, Day 1, and see it says Number System. Click on that, okay? And then this is just a page with all the links on it. So this is all the stuff that we're going to do. We're probably going to do that on Orientation Day because we have so much to do with virtual learning this year. But right here, this is the PDF of what I'm pulling up on the board. Here is your activity, real number system. So if you click on that, it takes you to a Google slide. And what I would like for you to do is put your name up here. So I'll know whose stuff I'm looking at, just so I know. This is not graded. Please don't have a spasm or anything. This is just to kind of see where you are and what you know. It's just a click and drag. So you click a number, and I want you to drag it and drop it into the smallest section that it belongs in. So like if I had this one right here, 0.6, and it does have the bar on it, which, remember, the bar means that it repeats. So I have a 0.6 that repeats. Well, that by definition that's a rational, and I can't go any smaller than a rational number. So I drop it into that layer. Okay, so you want to go the smallest layer you can. So like 0, the smallest layer you can. Is it rational? Yes, it is, but that's not the smallest layer. Is it integer? Yes, but that's not the smallest layer. You want the smallest one, smallest subset. Okay, but go through that, save your name on it, and then when you're done, share it with me so I can actually see it. Okay, you'll do that, and then join me in the next video.